input and lecture notes by Professor Neelam ma'am. So, first of all, I would like to call Professor P.K. Singhal sir. Please provide a welcome speech to ma'am sir. So, then we start.
Yeah, thank you, Dr. Amit. Dr. Neelam Srivastava, madam, a very senior professor from UP Technical University, and we feel honored with your gracious presence that you have given a very precious time, and all the participants who have joined here, and few more are expected to join shortly, and this program we are we have been organizing with the support of the Institution of Electronics and Telecommunication Engineers, Bhopal chapter, and Institution of Engineers India, Gwalior chapter, and Dr. Amit Yadav is the main organizing force. So, without taking much time, I invite Dr. Neelam Srivastava to make presentation, and Dr. Amit Yadav is the main force behind organizing this wonderful event. So please, madam.
Thank you so
So,
much. Yes.
uh, ma'am, I want some short introductory about you, if you permit me.
Yeah,
Okay.
please. Sorry.
Yes.
First of all, I would like to introduce our speaker, ma'am. Dr. Neelam Srivastava is a professor in Electronics and Communication Engineering Department, IET Lucknow. She also serves as a head of the Electronics and Communication Engineering Department at IET Lucknow. She also served as other positions such as Chairman, Board of Studies, Electronics and Communication in IET Lucknow. She is a Chairman of IQAC Cell. Dr. Neelam Srivastava ma'am has completed her PhD in Electronics Engineering from Lucknow University, Lucknow. She completed her MTech in microwaves from IIT BHU Varanasi. She has her Bachelor of Engineering in Electronics from Madan Mohan Malviya Technical University nowadays. It is situated in Gorakhpur. She has supervised 6 PhD theses with 6 in progress and about 17 MTech theses in her area of interest. She is the author and co-author more than 57 research papers in various reputed international journals and 20 international conference proceedings and 16 conference. She had reviewed more than 150 manuscripts of various reputed international journals. Her 20 research paper have more than 500 citation at Google Scholar data. She works in the field of radio frequency and microwave engineering, optical communication, cognitive radio network, wireless communication, and microstrip antenna. So I would stop here, and I would like to call our speaker, ma'am, for today webinar on new paradigm shifts in wireless communication. So please, ma'am.
Thank you so much, Professor Amit Yadav, for your kind words and talk about my journey in such a nice manner. Thank you, Professor Singhal. We are meeting after a very long time, but we had association from I think 2003 or 2004 in various rather MTech programs or somewhere in RDCs or somewhere in related to some research scholar work, because I also do research in the field of microstrip antennas. So we had we can say that formal non-formal association with you, not any college wise, and I am very thankful to IET Gwalior chapter as well as Institution of Engineer IET Bhopal chapter and Institution of Engineer Gwalior chapter. This IET chapter is very close to my heart because I used to be associated in IET Lucknow chapter since very long, and for one term I was here in Lucknow chapter. I was honorary secretary also, and since 90s I used to present lectures in so many conferences organized under IET umbrella. Similarly, the Lucknow chapter of Lucknow chapter of Institution of Engineers also. I used to go many times for different lectures and conferences. So I feel very privileged when I got this invitation from Professor Amit Yadav. And so now we start our formal webinar topic. The topic of interest of today is the wireless communication. I'll share my screen. If we talk of old days in 90s, because IET is yes.
Yeah, your presentation has not started. Shall I guide you how to start presentation on this?
No. I haven't started. That is why.
Okay, fine. Please continue.
Yes, in 1990s, I started giving lectures on all these topics when even the internet was in you can say research mode, and we keep on talking that what will happen communication in rural, how to lay the optical fiber, how it can be the fiber network. All those developments were moving from our eyes. This BSNL was one of the very important component in all these developments in communication. Now so many other companies have come. So that is why I have chosen the topic as new paradigm shift in wireless communication. So earlier we talk of even basic communication. If we talk of our landline, then it was a simple copper wire, and then from copper wire, because as the information increases, there is always a bottleneck of bandwidth. So to cope up the bottleneck of bandwidth with the increase of data, we keep on trying new technologies, and we keep on giving new terminologies to all those research. So we divide this communication portion. Here when we are talking of communication, means we are talking in terms of electronics engineering. That is, we want to share the information from one point to another point. That is our aim. Now the other point can be very near to us, or it can be very far. So the technologies used depends upon for which particular application we are designing our communication system. So initially we were having the wired and the wireless communication, and in both the areas there is a lot of development. For example, if we talk of a very simple example of wireless communication, when we talk of our landline phones, so we were having the walkie-talkie phones, and we feel very privileged that okay, now we can have our handsets in our hands, and we can even roam in our room, and can be connected. So that was a very basic thing from where it starts, wireless communication, and we keep on changing or keep on developing how to increase the data rate and how to increase the distance of communication, long distance as well as more bandwidth. This was the challenge for all the time and even today, because every day the applications are increasing, and when the applications are increasing, again the bottleneck is the bandwidth. So we go for different ways. That is in the wired communication, from this simple copper wire, we switch over to twin cable, we switch over to coaxial cable, then we switch over to optical fiber. Then from the optical fiber, there is a multi-mode, and then the single mode, and so on. When we switch over to wireless domain, there are more challenges. there are more challenges in the design parameter. When we talk of optical fiber, there are more challenges in you can say the when we are laying the network. So whenever we start, the basic need of any human being is sharing of information to express the thought. That is a basic thing. And this wireless communication or the wired communication, because we are today talking of wireless communication, that is why I am saying, so whether whatever be the media, be it wired or be it wireless, it is a great facility for a human in terms of mobility, because we are talking of wireless communication. So it is a great facility in terms of mobility and portability, suppressing the dependency on physical means of communication. That is, we can keep on roaming here and there, and we can share our ideas. So that is the theory in which we are moving. And if we talk of the first phase of wireless and mobile communication, which we given name as generations of wireless communication, and in generation, it is the first generation which comes with the analog system, and from there we keep on inputting uh, in every component, be it the system, be it the techniques, be it the media. All these things we are keep on changing to fulfill or satisfy the need of present data communication or present information to communicate it to distant place. So what are the basic things? That is a high data rate. It is the need of today's communication. The data rate should be high because data is high. Easy and corner to corner accessibility. High quality video and audio communication, which we need today in webinar also. So we can see practically nowadays in our day-to-day activity, all these things are required. Like wherever we are having, maybe at rural place or maybe at rural place or maybe at a very busy place, we should have a accessibility, easy and corner to corner accessibility. It should be easily connected, and it should be connected to the last point. AR and VR communication, low latency. We do not afford much latency. Gone are the times when we call to any foreign countries and always we feel there is a lag in the voice. So nowadays we are not feeling it, and because not only voice, we are transmitting many more things along with voice. So low latency is a need of today, or is a requirement of today. Adaptability means with time the things are changing, the technologies are changing, the demands are changing. So it should be whatever technology, whatever systems we are developing, it should have the adaptability to change. Flexibility, etc. are the essential requirements nowadays in the field of some basic applications I have mentioned here, in which the backbone is the wireless communication or the wireless networks. They can be medical, it can be transportation, it can be broadcasting, it can be defense, it can be weather forecasting. It is very common nowadays. Whenever we are leaving our home or whenever we are going to another city, we see what is the forecast and we plan our journey according to the forecast. So forecasting, tourism, in a similar way, whenever we want to plan something, we want to go somewhere, we just sit on the Google and we search each and everything, whether it is a booking or it is a taxi or it is a air flight or it is places to see. That is a tourism. Air traffic, industrial and home automation, this industrial and home automation is coming as a very potential applications where this 4G, 5G, which I'm coming just in a few minutes, it is going to help in industrial and home automation, vehicular communication. This we are already seeing in our day-to-day movement, education, and a lot more. Naturally, education is the field which we can say that in this present pandemic situation, this internet helps a lot, whether it is taking our routine classes, whether it is interacting with the students, whether it is getting information, everything that is in education. It was there was a major role of this technologies all the time, but in pandemic, even the school teachers, even the school teachers as well as these kids are become familiar with all these digital technologies, and naturally these are the applications, and at the back end, the electronics engineers, the biomedical engineers, the computer engineers, they are doing hard to cope up with the present circumstances. So this is how paradigm shift was first seen as wireless communication, and these shifts can easily be seen in today's era. Every time there is a change in the technology, change in the way of choosing the media, and way of different applications, and so there is all the time there is a shift. We can see these things in starting from very basic wireless generation. We term these wireless generations as 1G, 2G, 3G, 4G, and 5G. So if we see the changes, earlier the changes was in you can say 10 years, like 1980s and 1990s. The 1G and the 2G. What is the difference? The 1G was the analog. The 1G was the only wireless communication standard where we consider the analog voice from human to human. In 2G networks, which this 2G is supposed to be one of the very robust generation with many features, and many features used to get incorporated within this 2G standard infrastructures. We term that as 2.5G or edge networks and all that. So what was the basic difference? That is, the analog systems were converted into the digital voice, and we have started a very low speed of data. We can call this as SMS. It was one of the very important application, and we always feel very relaxed or very when we send any message to our receiver side. So if we see the speed and all the basics of all these, data speeds was up to 64 kbs. Use of digital signals instead of analog enabled services such as SMS, MMS, multimedia messages, and provided better quality of service. When we were doing the 1G, the quality of service was very poor, and as soon as we leave big cities, for example Lucknow, even just outer, these signals gone. So there was a quite large change when we shifted from 1G to 2G. As far as the user is concerned, user become very much comfortable when we started the 2G networks. If we talk of 2G to 3G, you can see here the size of the phone become bigger, and the screen is visible, means there is a transmission of pictures also. So the speed was up to 2 megabits per second. Increased bandwidth and data transfer rates. Send and receive large emails, that is emails have started, email messages, and we start with the broadband capabilities. We start the term broadband capabilities. So bandwidth also increases. Then we switch. Am I audible? Everything is clear? Is there any issue?
No, ma'am, it is okay. It is okay. All right.
Okay. So when we shift from 3G to 4G, 2010 we can say, mobile broadband, as I said, increment in the broadband, high speed data, internet access. And when we talk of 4G, IP based networks started, high speed internet access was there, and apps started coming. So they start supporting interactive multimedia, voice, video, wireless internet, and other broadband services. High speed, high capacity, and low cost per bit. Cost also start decreasing. I remember our days when simple voice calls were 15 to 20 rupees per minute, and you can think of the today, it is almost free. So high speed, high capacity, and low cost per bit. Global mobility. From here, the global mobility started. Service portability is the concept coming. That is, you can switch over from one service provider to another service provider. That is a very important concept which comes here, and seamless switching. I mean, handshaking become very hands off become very smooth. Variety of services, that is quality of service, scheduling, all these things become very easy. And one of the very important thing which come as the ad hoc networks and multi-hop network. We cannot simply say that okay, this is the time when this thing comes. Many things are coming all together and they are converging at one point. So these ad hoc networks and the multi-hop networks also start developing. So when we switch over another, if you talk of another era, that is 4G to 5G, in which we are here, somewhere we are having even at remote places we are having 3G facilities, somewhere it is 4G, somewhere it is 5G. So every sort of things are going all along. But if you see here again, basic thing is, as I told you, the bottleneck is the data rate and the bandwidth. So data rate increases to 10 Gbps. Here also 4G was not switched over to exactly 5G. Some intermediate generation networks also comes. Latency increases. Similarly, we talk of availability. You are able to connect anytime and from anywhere. Then one important point which I have mentioned here is reduction in the network energy usage. This is also energy conservation or energy saving is one of the very important parameter when the applications are increasing, when the usage are increasing. Nowadays you can see these smartphones, we continuously keep on surfing our smartphones, sometime for some official purpose, sometime for some entertainment purpose, sometime for another applications. So when our phones are in continuous use, naturally the battery is one of the very important challenging factor. So this battery, the life of the battery is another challenging area in which lot of work is going on. And here we got a quite good success, that is 90% reduction in network energy usage, up to 10-year battery life for low power IoT devices. This, the term IoT I am just mentioning here, Internet of Things. Same paradigm shift we have represented by a pictorial diagram. You can very well see here. If you see the left side and the right side, very interesting things. By very interesting things, it is explained. 1G, for example, you are moving on your skates. When we talk of 2G, we start traveling on our cycle, and then the car, and then the aeroplane, and then we can say fast, more fast. And if you talk of the applications, you can see the applications keep on increasing. SMS and MMS, internet access. Nowadays, we feel even you can say Wi-Fi access in our planes also. When we are traveling long distances, there also we can have the connectivity. So then video call is a very important feature nowadays to get connected with your children, with your students, with your colleague. This is a very important feature. Very earlier days when it was started, it is considered as luxury. But nowadays this video call or a continuous internet access is a necessity. It is no more now a luxury thing. Then mobile TV HD, because people are roaming from one point in various jobs. So mobile TV is again very important tool, very important applications where if you are having free time, you can utilize it by seeing whatever you want. Similarly, cloud computing is another very important applications which we are using today, because we have started with the we can say floppy, and where we talk of storing kilobits data, data in the range of kilobytes, and then megabits, and then we get pen drives of in the range of GBs and hard disk, all these things. But they all are having limitations. And if they get corrupted, it is very difficult to retrieve the data. So the application comes as cloud computing. That is to put your data on the internet itself, where it's a very similar to your pen drive, but it is not a physical storage. So this cloud computing is also changing way of working. Earlier days when we were moving, we used to put so many things in our bags. When we are going for any official meeting, we were having so many things in our bags, so many papers. Now we can move paperlessly, and even we don't need to put our pen drives or like that, because good internet connections are everywhere, and we can simply take our information from the cloud whenever we need. One very different applications which is coming is the robotics. Again, in our childhood, we were seeing a TV serial of Star Wars, and at that time it was we were not able to even think that we will get a society very similar to that. Not, because that is an imagination, that was a series, that was a movie, but now we are moving very closer to those things. So robotics are the field where it is helping the human being in many ways. Wherever there is a danger, We can save our humans, we can send the robots, we can control remotely. And whenever this is one thing, and second thing is, second type of applications can be, if something is to be done in a multiple type, why to waste the intelligence or the intelligence of a human being? A robot can very easily do it. So nowadays so many applications of robotics is coming in the different fields, maybe as assistants at home, assistants at office, or assistants for various industrial applications. Similarly, the automobiles. The Tesla is the example of one of the very advanced technology, where they are coming very close to the car, which is you can say unmanned car, not 100%, but very close to those things. So these are the applications which is only possible because of the 5G, and we call all these things as you can say internet of things, internet of everything, and so on. Amit,
Yes, ma'am. Yes, ma'am.
what is my time limit?
Ma'am, it is 5 to 6 p.m.
Still I am available.
So whenever you are going to be, yes, ma'am.
Fine. So now, so these were some of the applications which we are seeing in our day-to-day activities, and thousands applications are still coming. So many startups have come up which are making use of these technologies, and they are making our life easy and easy. At the present time, we are going towards, or the researchers are, because 5G is now we have given the standards. We are working on infrastructures. We are working on developing technologies to make it convenient, and to make it approachable to a normal, even average human being. So if we talk of what will be there in 6G and beyond, इतना कुछ तो कर चुके हैं, अभी क्या बचा हुआ है? So coming to the thought process of the entire world, which is termed as what are the goals? What are the goals of the thinkers, that how our society should be after 10 years or after 15 years. So keeping that in mind, society, UN, we can call it as we term these things as Sustainable Development Goals, SDP. I'm just mentioning this first. This was adopted by, this was the agenda till 2030. It was in the discussed and chalked down on the paper, and make the policies in the year 2015 at United Nations Summit in New York by these. They developed the agenda of this board is to have 17 Sustainable Development Goals, termed as SDG, with 169 associated targets, which are integrated and indivisible. That means these targets or these goals are nowhere going to work or sustain independently. And we'll see, I'll come back to the earlier slide, that all these goals, many of these goals and targets or sub-targets, the backbone is the communication technology. wireless communication technology. So coming back to these goals, these 17 goals, if we talk of, these goals are like every human being or every life, we can say, not only the human being. uh, when we are talking of life, means we are talking of life underwater, we are talking of life on land, and we are talking of uh, the entire environment. So we as a humanity, these development goals switch over, I mean, talks of humanity to persist. So these goals talks of different concepts: no poverty, zero hunger, good health and well-being. These are the things which is required to have a healthy person, healthy, you can say, I mean, uh, humans, healthy underwater जो भी हमारे lives हैं. So for all that, that is, there must be peace, justice, there must be partnership, there must be clean environment, there must be gender equality, there must be quality education, and there must be affordable and clean energy, all these things. So to meet out these goals, which we can in one line or one word we can say is, leave no one behind. Like, join hands not only with the humans, but with your all animals, all trees, all livings, and develop everyone. So this agenda is to leave no one behind, and these mobile technologies are core for connecting and internet access. We are thinking of 6G as a new era, that is Internet of Intelligence, I of I. अभी हम बात कर रहे थे IoT. 5G we focus on IoT, and 6G we focus on IOI. That is Internet of Thing, means जो Internet of Thing we are using today in our daily. That is, instead of connecting with our laptops or with computers, there is a network which is connecting various things. Now the things can be your light, the things can be your TV, the things can be your you can say fridge, your washing machine, all these things. So we can have a network of things. That was the concept of Internet of Things. And now we talk of Internet of Intelligence, and that is connecting people. Connecting people was there in 1G, 2G, 3G, 4G, all. Connecting things, which comes in as IoT and intelligence. And for all these things, whether we talk of connecting people, whether we talk of connecting things, whether we talk of intelligence, the basic need is the universal access to information. Universal access to information is recognized as a crucial factor to achieve the UN SDGs. That is, again coming back, that is our new paradigm shift. Power revolution in digital learning. Mobile devices allow students or in general learning assets anytime, anywhere, which naturally enhance the literacy. Now we are not only dependent upon classroom teaching. There are so many materials available on internet. So even if at the rural places a person is having a smartphone or an internet connection, he or she is connected to the entire world. So we have the so naturally, when literacy gets the you can say motion, gets legs, and which was in one boundary, in one classroom, in one area. Now you can connect it globally. So naturally, when literally increases, literacy rate increases, it is going to naturally increase in the economy, and it will whatever there is a divide between rural and urban, it is going to reduce. Similarly, it will reduce the divide between rural and urban as well as gender divide. Days are the gone when we not gone, I'll not say gone, it is still in the process of gone, where so many limitations was there with the girl, wherever she has to go to school, wherever she has to go to the market, she needs security, she needs support, she need assistance or dependence on others. So that is with the help of these new paradigm shifts, this is a very boon for women as far as education is concerned, as far as their safety features are concerned. It is going to help a lot. So when we are talking of Internet of Things, or when we talk of 4G network, 3G network, continuously the security features are coming up. Continuously, so many apps are developing, which will feel the woman or the girl safer in their movement when it is moving, and they will get the life enhancing opportunities. Similarly, so it will going to help the economy, sharing of economy, and e-health. E-health is also very big, you can say, easiness in the bring very big easiness in the society, and we see this, we feel this, and we use this e-health services in pandemic time. Because of this COVID-19 scenario, nobody was able to move outside the home, so doctors have usage this e-health services in a very good way. They brought with very innovative applications to see their patients, to connect with their patients, to guide them and make their life happy. So coming to 5G, which was actually our topic, if we talk of 4-5 components of this 5G, that is high data rate, massive communication, because we want to know weather, we want to know date, we want to know time, everything we want to know by our single system. So many gadgets which we were having, now they are converged into just one system. So naturally, there is a massive communication. Uniform coverage means whether we are at the rural place or we are having at the, you can say, highways, or whether we are having at under you can say malls or metropolitan cities or high-rise building. We want uniform coverage, and 5G is the tool which is giving this. Then green communication means energy saving. That is again a very big challenge of today, and this 5G is meeting this challenge in one or the other way. And then the security and privacy. You can say our elders can be safe at home by making use of some gadgets at our home, by making use of some security systems at our home. When we are outside from our home for job or for the school purposes, we can track our homes, which comes under we can call home automation, we can call, or security homes, or we can call smart buildings. All these things, they are going to be help in a very good way, making ease of our society. So we talk of massive machine type communication traffic, which was again the extension of the earlier. Massive machine type communication means data rate increases, supporting Internet of Things. We are good, better performance in respect of voice, data, and video applications. We can now stream. We can have online features. Anybody can be live on the Facebook, or he or she can be live on Messenger, or wherever a person wants. So it uses the cloud-based networks, that is called a CRAN, and a core. And CRAN is a new term coming up, which is making use of naturally, when data is increasing, the traditional multiple access scheme is nowhere going to work. We have to work on all those access techniques also. And in that direction, we have this NOMA and MIMO. NOMA is the non-orthogonal multiple access schemes. This orthogonal multiple access scheme is also one of the very, you can say, unique feature in increasing the data rate and increasing the access of many parallel access. But NOMA is again one step ahead of this orthogonal multiple access schemes, OFDM, which we call as. Then massive multiple input outputs means instead of in a normal communication system, we talk of a transmitting antenna and a receiving antenna, and naturally in between we are having some communication system and some media. And extending to that, we are now multiple inputs and multiple output antenna array systems. Means now multiple antennas can receive the signal and multiple antennas can transmit the signal. How it is going to help, that we'll see later on. So as we all aware, we are having, when we talk of any layer, when we talk of any network, the networking is in terms of layers, and one of the very popular model was the 7-layer model, where the lowest layer we call it as a physical layer, and then the data link layer, then we call as a network layer, and all those things. So I'm not going in that detail. I'm just talking these layer technologies with respect to 5G and IoT. So if we talk of 5G and IoT, if we see these phase changes, these multiple access techniques in 2G was TDMA, time division multiple access. In 3G it is CDMA. In 3.5G it is MIMO, which is called as multiple input and multiple output. And then in 4G it is OFDM, that is orthogonal frequency division multiplexing. And OFDMA is orthogonal frequency division multiple access. How the things are changing in 5G, let's see. I'm not going in much detail of these. If you see the challenges of today with the current systems, so 5G is targeting ultra high data rates, nearly 10 Gbps, with a new term which is coming up as eMMB. That is, हम इसके पहले बोलते थे broadband networks, and now a new term has come up as eMBB, that is enhanced mobile broadband. Let's see what is this all about. So if we talk of connectivity, it is LTE networks. It is supporting 100 to 1000 users per cell. But in 5G, it is expected to enable man-to-man and IoT communication, and we require tens of thousands of connected devices oblique sensors per square kilometer. So you can see what is happening today and what is the need of tomorrow. So for all these, EMTC, enhanced machine type communication, is the answer. Similarly, if we talk of latency, response time, it is in 4G, it was 30 to 50 milliseconds. When we talk of, with this latency, they cannot support applications such as autonomous vehicles. क्योंकि इतनी देर में तो accident हो जाएगा. So it is in 5G, it is so we have to work on latency. So in 5G, we enable autonomous vehicles, drone communication. Drone is another very good feature, and it requires the URLLC. We define another parameter called as ultra reliable low latency communication, where the response time required is less than 1 milliseconds. Talk of the technologies, as I told you, it is massive MIMO, millimeter wave MIMO, non-orthogonal multiple access NOMA, cooperative communication, and cognitive radio. MIMO is not a new term nowadays. Massive MIMO and MIMO means it is an extension of that. Similarly, orthogonal multiple access scheme is again not a new name today. It was there in even 2.5G or 3G. So non-orthogonal is again a new feature. Cooperative communication means not the independent communication between transmitter and receiver. There must be another point which is ready to cooperate. So it's a simple concept which is ready to cooperate. So it is the cooperative communication. And cognitive radio is a device or is a concept, works on the you can say the holes or the space, utilizes the space when something, suppose we have a road and some vehicles are going. So whenever we want to pass, we keep on tracking the road, and when we see that the road is free, we keep to pass from one side to another side. So cognitive radio basically concept on the same concept, works on the same concept. That is, whatever the gaps are there, they try to send the data in those gaps. But it's not that much simple. So many things are there. Massive MIMO, you can see we have large number of antennas at the, you can see from the last figure here. Massive MIMO, if you talk of a simple MIMO, if you talk of, we can have 2-4 antennas at the transmitter and receiver, and this is a simple way of representing it. So each receiving antenna.
Amit, just check what happened. Voice connection has been lost.
Any issue?
Amit?
Yes, sir. But it is, sir, from my side, it is okay, sir.
Am I audible?
Yes, sir. Sir, you are audible, sir.
Amit, am I audible to you?
Yes. Sir, my voice is there or not, sir? You are audible. Very well, you are audible.
Amit?
Yes, sir.
Am I audible?
Yes, sir.
Some
Yes, sir. You are
connection.
audible, sir.
Yeah, please. Yeah, madam, please
You are audible.
continue. Probably some internet issue was there.
Should I continue? I'll finish it within 2-3 minutes.
Oh, sure. Please continue as much, take as much time as you take. Please continue.
Okay. So there is a difference in massive MIMO. You can see I'm not going in much detail. That is more antennas at the transmitter and the receiver side. And then if we talk of millimeter wave wireless communication, you can see millimeter wave means the wavelength range is changed. So jo abhi, the current system was using the spectrum in up to 6 gigahertz, that is from 300 megahertz to 6 gigahertz. Now we can go way beyond that. We can see here this 5G from, you can see 6 millimeter wave is from 6 gigahertz to 300 gigahertz, and quite large spectral band is now available, which we can make use and get a very high data rate. Just very easy way I will explain what is NOMA and what is orthogonal multiple axis. You can see the color, we all know as an electronics engineer that different color represent different wavelength range. So what we can see here, the different colors is representing in orthogonal multiple axis. Everyone is all different is sharing this having same power with different time or different code or different frequency. These can be the parameters. And what we did here in non-orthogonal, even in one assigned time slot, we are sending two different signals, which are difference in their you can say time or frequency. Very simply, I just want to explain you what is cooperative communication. In general, we talk of this only, that is from source to destination, one link. And when we talk of cooperative communication, another data or repetitive data we can send to a relay. And from this relay, it will come to destination. So it is coming via two paths. So if there is some problem in one path, the second will work. So it is a cooperative communication. If we talk of a cognitive radio, cognitive radio enables spectrum allocated to primary/secondary license users. That is, we define as two users, primary users and the secondary users. And cognitive will see work as a device. Radio means it's a device, transmitter receiver system, which give you a slot for the secondary user to transmit its data, to be opportunistically used by secondary/ and license users. It's a simple concept of cognitive radio. I'm not going in much detail. Very simple, in a very simple way, I'm explaining this 6G, which we need, that is interconnection of physical, biological and digital world. We are already working in digital work. We have started working in physical world, and let us see what is biological world. So this is in a triangular shape. These are the three corners as digital world, physical world and biological world, and we want to connect in the real time mode. And the applications can be ubiquitous, compute and AI. For 6G, the artificial intelligence is a tool to help in connecting all these interconnection between physical, biological and digital world. Then we need precision sensing and actuations, means we have to develop good sensors, good Then we have to have human machine interface. That machine can interact with the human directly, another human is not required. And multi-sensory rendering. So all these are the with the help of this we come to another era of wireless networks. So that's all we want to. Something can be wearable devices. Wearable devices में अभी भी we are using the simple way में we can call as earphones. Some of us are having the pacemakers. Some of us so many things are already come up, and so we have wearable devices. We have skin patches and bio implants. Touch screen typing will likely to become outdated. Gesturing and talking to whatever device we use to get things done will become very normal. As a consumer, self-driving concepts of car, domestic service robots, health security, automation, etc. So many challenges, so many research is needed, and so many collaborations will be required to get the next generation network. Why I'm saying the next generation network? When one comes, like after some time, when 6G comes, we will start thinking in direction of 7G. We will start thinking new in that era. So always we call as next generation network. And this is also a path towards the 6G, and that's all about I want to share with you in this webinar. And once again, thank you very much to all of you for giving me the opportunity to share my views. For any questions, I'm here. I'm just stop sharing, and
So it was a wonderful and eye-opening lecture, and Madam has given so many details of wireless communication, starting from basics to super quickly. Now, it's time for the audience to, if they have any query, please put forth your query.
Ma'am, one question from my side. Ma'am, what is the difference between IoT and IOI?
I told you in the last slide that is we are moving towards the three things: biological interconnection, machine interconnection, and the data interconnection, which we are talking about. So IOI is the networking of intelligence. We need not to speak.
Okay, okay, okay. It can pursue by the intelligence.
जो हम सोचे वो सामने वाले को जो हम पुराने अपने वेदों और पुराने शास्त्रों की बात करते थे कि वो मेडिटेशन करके समझ जाते थे कि व्हाट इज गोइंग ऑन, व्हाट इज हैपनिंग देयर. महाभारत में भी जो हम लोग बोलते थे ना,
Yes, yes, yes.
द सेम थिंग.
Okay, okay, ma'am. Because we have listened.
Just like telepathy, madam.
Sorry,
Just like telepathy.
you can say telepathy is not nothing technology behind that. But when we talk of internet of intelligence, please, there will be algorithms, there will be devices which work on that. It sense those senses and work on that.
Any other person who want ask something? Anyone? Okay, sir. Please give a vote of thanks to ma'am, and here we are going to stop.
We have with us Dr. Anupam Vyas from Bundelkhand University and lot of research scholars I am able to see here. So I am on behalf of the Institution of Electronics and Telecommunication Engineers. I am very much thankful for Dr. Neelam Srivastava for sparing her valuable time and giving us detail of wireless communication. Certainly, the point, your illustration will help all the research scholar faculty member to enhance their research work, and we are also very much thankful to all the participants and all the dignitaries who have joined here. So thank you very much for again Dr. Neelam Srivastava madam. Certainly next time we shall have a meeting in physical form also at some place.
Amit,
So
mute your mic.
Dr. Amit Yadav, would you like to add anything more?
नो मैं नो बस मैं इतना ही कहना चाहूँगा मैम, थैंक यू सो मच। और स्कॉलर्स का जो फीडबैक है वो बहुत पॉजिटिव है मैम। देयर आर पीएचडी स्कॉलर्स एंड एमटेक रिसर्च स्कॉलर्स एंड आवर फैकल्टी मेंबर्स। सो थैंक यू वंस अगेन मैम
And
for
you
your
can correct me anytime. No issues.
all right ma'am, and once again thank you very much ma'am for your precious time and give us a very knowledgeable lecture regarding wireless communication. Thank you once again ma'am.
Thanks
Thank
a lot. Take care.
And happy